Hey, everybody. So we're looking at 12.3 today using what's called indirect measurement. Okay, before we get into our first example, though, I want you guys to try this warm up here that basically has us recall what we were learning in chapter 11, because that's actually a big part of what we're doing today. All right, so this first problem here is telling us that we have two triangles that are similar, and it's asking us to find the length of EF. Okay, so EF down here, which we've called X here. Okay, so you guys, remember how to do this. Go ahead and set up your proportion, all right, of course, setting ratios of corresponding sides equal to one another, and see if you can remember how to find this missing side length. Okay, after that, it says along with angle, what are the two other triangle similarity theorems? All right, so see if you can recall those two things. So try out these two warm-ups real quick. Okay, so on number one here, since these are, similar triangles, we know we can make a proportion out of their corresponding sides. So I would start with, this side and its corresponding side. I always work left over right. So 6 over x would be my first ratio. And I can set that equal to the ratio of two other corresponding sides and 8 over 24, left over right. Okay, and then from here, you guys remember just cross multiply and solve. I always say this, but it looks like we could reduce this, right? 8 does go into 24, but I'm going to choose not to. I'm just going to go ahead and cross multiply. So 8 times x is 8x, setting that equal to a 6 times 24. Let's see what we get there, 144. Okay, and then, solving for x, dividing both sides by 8. It looks like x is going to equal 18. All right, and yeah, there it is. There's no units on these triangles, but today we probably will see some units. So if there is, we would include it. But for now, we're good. Okay, so there's just a little, a way of remembering how to do that. The other problem, if you guys remember, we had angle similarity, a way of figuring out that two triangles were similar. That was the first one we learned. If you guys remember, the two others that we know was side angle side and side similarity. All right. And today we're going to probably run into, a couple, if not all of those. All right. So, yeah, that's our little review. Let's go ahead and get into what we're doing. The first thing we're going to start with is, just a question. You don't need to copy this, but this is just kind of the purpose of this lesson. So basically, here's the question I want you to be able to answer by the end of this. And this is it. It says, what is the difference between direct and indirect measurement? Okay, and how would you use indirect measurement? Right, so that's kind of the question. What's the difference between these two things, direct measurement, indirect measurement? Let me just start with direct measurement. Okay, if I had a measuring tape and I wanted to measure how long a piece of, plywood was, okay, I would directly measure that. I would use a tool and I would get that measurement. All right, that would be an example of direct measurement. Okay, the question is what is an example of indirect measurement? How do I measure something without using an actual, physical tool, I guess? All right, well, today we're going to kind of figure that out. Okay, so go ahead and get the title at the top of your paper. You don't need to copy this whole sentence here, but this is just going to kind of get us into the right headspace of what's going on here. So go ahead and get the title. Okay, so let's go ahead and read through this and let's kind of draw what they're doing. And I want you to draw this along with me. So here's what it says. Suppose the sun is shining. All right, so let's just start with that. On your piece of paper, draw the sun. Okay, here's my sun. Okay, so the sun is shining. Here, I'll make a big sun. There we go. Okay, so it's shining. Here's what it says, and you are standing near a flagpole, but out of its shadow. All right, so we have a flagpole. All right, here's my flag. There we go, USA, right? And then it says, I'm standing next to a flagpole, but out of its shadow. So over here, let's go and show, okay, here's me. Hooray. All right. So, and there we're talking about shadows, right? So the flagpole has a shadow along the ground. It's being cast from the sun. All right. And it says you will cast a shadow as well. Yeah, I would. So here's my shadow being cast. Okay. And here's the next thing it says, you can assume the rays of sun are parallel. Okay. The rays of sun, if you guys can imagine, the rays of sun would hit the flagpole and kind of go down like this. I hope that yellow is, clear enough to see, but that's kind of my ray of sunshine. And the sun would hit me and also, shine down. It's really what's creating those shadows. And they're telling us those rays of sunlight are parallel. Okay, what do you know about the two triangles form? Okay, what do we know about these two triangles? All right, well, here's a couple things we can probably add. If the flagpole is standing straight up and so are we would be at a 90-degree angle from the, from the shadow, from the ground. All right. And yeah, we have some parallel lines. If you guys could imagine, you don't need to write this, but these parallel lines and the ground itself. By the way, I didn't put myself perfectly. Let me read there. The ground should line up, right? The ground should not be on different levels. All right. So the grounds of that, and if you guys could imagine, we have our parallel lines, and the ground would be considered a transversal crossing our parallel lines. That means these angles here and here would be technically corresponding angles, but more importantly, we would know they're congruent. All right. So I shifted the ground again, but don't worry about it. But now we know that these are congruent. Okay, and this is just a long way of showing, look at, we have some triangles, some right triangles specifically, where we have two pairs of corresponding angles congruent. These triangles are similar. Okay, so yeah, what do we know about these two triangles? They are similar. Okay, explain. Well, our explanation is just this. I guess we can say because of angle-angle similarity, but the drawing is really the best explanation here. All right, so here's kind of what we're going to get into today. Imagine if we had a measuring tape. All right, we could measure ourself, and we could also measure the ground. All right, but what we would have difficult time measuring would be the height of the flagpole. If this thing is super duper high, we just have a measuring tape, we're not going to be able to figure out how long it is. But using indirect measurement, we will be able to figure it out. All right, and you guys can probably see how we're going to do it because we have similar triangles. All right, so let's try this out with another example. All right, so I guess here is another drawing here. If you want to put this is the same drawing, a flagpole and a person, though it's kind of flip-flop. If you want to put these values on your original drawing you just drew, that's fine with me. All right, so yeah, say we are 6 feet tall. Say the shadow we cast is 4 feet, and the shadow that the flagpole casts is 12 feet, and we are wondering what is the height of the flagpole. Okay, well, since we have similar triangles and we know the values of some of these side lengths of the triangles, we can create a proportion to find the missing side length, or rather the height of the flagpole. Okay, so that's exactly what we're going to do. And sorry, it's a little flip flop. If you want to redraw it, you can, but you can just put these values onto your drawings. If you're doing it, this is 6 feet, or a shadow's 4 feet. This one was what, 12 feet, I think it said. Okay, so yeah, with that, let's make our proportion here. So let's go ahead and do it. So I'm gonna start with the value that I don't know and its corresponding side. So h over 6 is going to be my first ratio. Okay, by the way, we have feet here, but I'm not going to use the units until we actually get to the end of this. Okay, and again, I went left over right for my first ratio. I'm going to go left over right for my other one, so a 12 over 4. All right, and yeah, there it is. We have a proportion that we can solve very easily to find the height of this flagpole. Okay, so let's do it. I'm going to start with 4 times h. All right, by the way, don't let the h throw you off. We're just using h instead of x. It's no big deal. Okay, equals 6 times 12, which is 72. All right, divide both sides by 4, and it looks like we're getting 72 divided by 4, 18. All right, and now we can go back and put our units. This is all in feet, so let's go ahead and say 18 feet. Okay, that is the height of our flagpole. Okay, and the cool thing about this is, this is literally something you could do yourself. If you were outside and you were on the same, I guess, plane as the flagpole, the same level ground, and you knew your height, and you could measure the length of your shadow and also the shadow of a flagpole, you could figure out the height of it using indirect measurement. All right. So yeah, that's the idea. And we're going to do just do a few more of these examples, but this is basically the idea of this whole lesson. Okay, so let's keep going. Okay, so I'm gonna have you guys try one out on your own here. This one is asking you to find the height of the palm tree. Okay, so this right here is what you're looking for, which by the way, when you go to write this, you might want to just call this thing X. That's what we're looking for. All right. And here's what we have. We have just a wall that we know is 1 meter high, and we can see that it's casting a shadow of 1.6 meters. The palm tree is casting a shadow of 7.2 meters. All right. And yeah, these are creating similar triangles. So you can make a proportion. Okay. The decimals, don't let it freak you out. Just use a calculator, and it's going to be the same as you always would do this. Okay. So go ahead and draw these and set up your proportion and see if you can figure out the height of the palm tree. Give it a try. Okay, so yeah, I'm going to start with my wall and the height of my palm tree. That's going to be my first ratio, and I'm going to work left over right. So a 1 over x is my first ratio, and I know that's going to be equal to the ratio of the other two corresponding sides, the shadows. So left over right, a 1.6 over 7.2. Okay, and yeah, let's go ahead and cross multiply. So 1.6 times x is a 1.6x, and 1 times 7.2 is 7.2. All right, last thing, solving for x, dividing by 1.6. So 7.2 divided by 1.6, and it looks like I'm going to get a 4.5. And we're talking about meters here, so 4.5 meters. Okay. Yeah. So again, that's indirect measurement. Basically, I guess a way of thinking about indirect measurement is it's a measurement technique that uses proportions to find measurements when direct measurement is not possible. All right. It wasn't possible for us to actually measure the height of this tree. We in our little scenario, we didn't have the tools to measure this tree, but we did have the tools to measure the height of a wall and the lengths of these shadows. So that's the idea, using proportions to find different measurements. Okay, let's have you guys try another one of these. I'm going to get you started on this one. Okay, but real quick, go ahead and just copy this one. You don't have to go crazy with these drawings. You don't have to draw a T-Rex and the person, or you can just make them really simple if you'd like. So draw this real quick, and then I'm going to get you set up on this problem because it's a little different than the others. Okay, so I guess first things first, this is actually another way of using indirect measurement. What's going on here is there's a person standing 4 feet away from a mirror that's laid on the ground, all right? And that mirror is 40 feet away from the T-Rex. And here's the idea. If they are able to look into the mirror and see the top of the T-Rex's head, then they create these similar triangle values. All right. So, it looks a little weird, and it's a weird idea, I guess. But yeah, this is something that you could actually do on your own. Go outside, put a mirror down, and and then measure all the distances, and you can figure out the height of things that are really tall, like buildings and other things that are almost impossible to measure with any common means, any direct measurement. Okay, so here's the problem. If you guys take a look, we have mixed units. Everything is in feet besides this. This is in mixed units, 5 feet, 9 inches. All right. And when we go to make our proportion, we do not want mixed units. We want everything in the same unit, which, it looks like almost everything is feet. So we want to convert this into feet. All right. So how do we do it? Well, here's the idea. 9 inches. Okay. We have to think, how many inches is 9 inches out of a foot? Okay. Well, how many inches are in a foot? 12, right? Okay, so I'm thinking, okay, if there's 12 inches in a foot and this thing is 9 inches, okay, what is this going to, turn into? Okay, well, we could actually just divide these numbers. Maybe that's the easiest thing to do. 9 divided by 12, that's 0.75. Okay, so 9 inches is actually 0.75 of a foot. All right, so I'm going to rewrite this, and I'm going to say, okay, instead of 5 feet 9 inches, I'm going to say 5 feet, actually 5.75 feet. That's probably the best way to write it. Okay, so if you ever see a problem like this that has, inches, you need to convert it, just take that number, divide it by however many inches are in a foot, which we all knew was 12, and then we figured out what it is. Okay, so these are the values that I want to use here. All right, so from here, I'm going to have you guys go ahead and make the proportion and try this out. All right, corresponding sides are the heights of the two things, and then the shadows. Okay, so make your proportion and see if you can figure out the height of that T-Rex. Okay, so my first ratio, the height over of the guy over the height of the T-Rex. So 5.75 over the height of the T-Rex, which is what we don't know, h. All right, and we know that's going to equal the height of the ratios of the shadows. All right, again, left over right is what I did before, so I'm going to do that this time too. So a 4 over 40. Okay, and yeah, from here, let's go ahead and cross multiply and see what happens. So 4 times h is a 4h, and a 5.75, oh, let me make it blue like I normally do. 5.75 times 40, let's see what we get. 5.75 times 40, we get 300, or sorry, 300, 230. All right, last thing, solving for h, dividing both sides by 4, and it looks like h is going to equal 57.5. All right, and 57.5, we're all talking about feet, right? So there it is. Okay, so that is the height of the T-Rex, which I'm not even sure if that really is the height of T-Rexes, but that sounds about right. Okay, so yeah, there's just another practical way of using indirect measurement to find the height or the measurement of something that would be very difficult. If you could imagine trying to measure a T-Rex, that was probably something that was hard to do. All right. So let's see. I have one more, I guess, idea here where I'm going to have you guys answer the essential question, and then we'll take a look at one more of these indirect measurement problems. But first thing I want you to do is go ahead and answer this. It's asking, excuse me, what is the difference between direct and indirect measurement? Okay, go ahead and just give me a short sentence and tell me the difference. What do you think? Okay, and then also add in, how would you use indirect measurement? Okay, well, what's its purpose? How would you use it? Okay, on number 2, this is just another example. Basically, this is just kind of another practical thing. Here's the scenario. This right here, even though it looks kind of funny, is a canyon. Okay, so we're kind of looking down at the ground. You can imagine being in a helicopter and looking down at a canyon. So this is the canyon right here. And here's basically the idea. We're wondering, what is the distance across the canyon? Okay, well, here is, kind of what we could do. We could place a point on the other side of the canyon, and then we could basically measure these distances. We could say, okay, there's a point here. I'm trying to go across from this part of the canyon. So this is 24 meters, and then I could put another point here. This is 42 meters, and then, maybe this is where I'm standing right here, and I'm standing 35 meters away from the canyon. All right, so this is all stuff that we could measure ourselves, right? Okay, but we wouldn't necessarily be able to measure the distance across a canyon. That would be very difficult to do. But since we can get these values, and if you guys notice, what's being created are these similar triangles, which, by the way, they're similar because these angles here, these vertical angles, are congruent, and these lines here would be parallel. Okay, which that'd be a transform. No, what am I trying to say? Parallel lines and transversals. There we go. Transversal. This would be a transversal right here, meaning these angles would be they'd be congruent. All right. So basically, again, we're using angle-angle similarity here to create these triangles. But I'm kind of rambling now. But now we can make a proportion and find the distance across this canyon. Okay. So again, go ahead and try it out. Make sure you're making your ratios with the corresponding sides. Okay. Be careful with that. Try it out. Okay, so the distance across the canyon and the distance I'm away from the canyon would be corresponding sides. Okay, so my first ratio, I'm going to do d over 35 and set that equal to, the distance from, from this point to this point. All right, I don't know how to describe that, but there's a point here that we maybe threw a rock down on the ground, and this is how far away that is and how far away we are. Okay, so yeah, there's our other corresponding sides at 24 over 42. Okay, now we can cross multiply and see what happens. So 42 times d is 42d, and 24 times 35. Oops, let me try that again. Looks like we're getting 840. Last thing, divide both sides by 42. And it looks like the distance across the canyon is going to be 20. It looks like we're in meters, right? So 20 meters. Okay, so yeah, this is a cool lesson. I like this. This is like really practical ways of using geometry to find measurements. This is how people do this. If you ever guys see like those guys on the side of the road and they post up those little like tripods with like some like little camera in it and they're looking through it, they're measuring, or I guess they're getting a line of sight on something, and they're using that to use indirect measurement to figure out the height and the lengths of things. So that's just kind of interesting. Okay, guys. So yeah, that's going to be that for today. I'll see you later.